Now we'll look into the solution that we have inside our cloud campus. Okay, so let's go through the first solution, the cloud managed network solution. Okay, again, these are the architecture for cloud managed network solution. Again, we have our NCE campus. Again, we have the multiple network tenant in below. And then we have the value added software as a service. These are the application. Okay, and actually this is similar as what I explained before. We have NCE here, NCE, and then it will use netconf. Okay, netconf to monitor all the devices either through internet, or you can also go through maybe WAN network or directly through the LAN network. Okay, so the iMaster you use SNMP, the netconf to monitor all the network devices. And then again, our NCE campus will use RESTful API, okay, or the NavMount API to communicate with the application to exchange data such as syslog, okay, and maybe configuration and other things. Okay, so this is just repeating. Okay, so in our cloud managed network solution, there are some key technologies that you need to know. The first key technology is the netconf YANG protocol. Okay, so what does this netconf actually do? The netconf actually provides, okay, the netconf actually allow you to add, modify, or delete configuration of a network devices, and also to obtain configuration of the network devices. Okay, so how netconf actually get all this information is our NCE campus will act as a netconf client, and the switch, okay, the switch on devices will act as the netconf server. So initially, our NCE campus will send a netconf message. So we send a netconf message, okay, to request for the specific information, such as maybe now our NCE want to get the configuration. So he will send a netconf message to the device, and then our device will receive, and then it will feedback the configuration to our NCE campus. So these are the first key technology, netconf. Okay, so the second key features that we have here is admission authentication. So admission authentication is basically the features where we can use our NCE as a authentication server. Authentication server. Okay. So basically in our cloud campus, we support different type of authentication. The first one is portal authentication. And in portal authentication, we can use either username or password to log in. And we also support anonymous authentication, SMS authentication. Okay, you can use Tencent, Sina, Weibo. You can also use WeChat to authenticate, Facebook, Twitter, and passcode authentication. Okay, so beside portal authentication, we also support PPSK, MAC address authentication, and 8021X authentication using built-in radius, or you can also connect to third-party radius for 8021X authentication. Okay, so our NCE campus, right, it will use different type of transmission protocol to communicate with the device for authentication. So it will use netconf for configuration, and it will use HTTP2 or radius for authentication. Okay, for authentication. So, okay, so beside all this, okay, our NCE or cloud campus actually also support open authentication. Okay, where we can able to interconnect with third-party portal server for authentication, or we also able to interconnect with social media such as Tencent QQ, Sina Weibo, WeChat, Facebook, and Twitter. Okay, so these are the one of the key features that we have inside our cloud campus. Okay, so these are just some of the process for the portal page push policy. Okay, so basically in our cloud campus, we can specify the scenario that we want. Okay, for example, maybe we want only the wire device to be pushed. Okay, or we want to push the portal. Okay, we only push the portal to wired device. So in our NCE campus, we can specify this one. So after you configure on our NCE campus, okay, it will detect the device whether it is connected wired or wirelessly. So if it is connected to wired, it will push the portal, and if it is connected to wireless, it won't push the portal. So this one you can configure in our CloudCampus. So beside this, okay, we can also define or specify what are the scenario that you want to push the portal, such as we can specify the area, the access device, the time, the terminal, and the custom parameter. So for area, maybe you can specify the sites. For example, maybe in the network we have site 1, and then we have a second site 2. So you only want to push the portal authentication in site 1. So inside the NCE campus, you can specify the site's name. Okay. And for access device, you can specify whether this portal will be pushed based on the devices. You can specify maybe you just want to push the portal to the switch, or maybe only push to firewall, AR, AP, WAC. Okay, so you can also specify this inside your NCE campus, and you can also specify based on ESN or SSID. Okay, so this one you can choose based on your requirement, and then you can also specify the time. For example, maybe only working hours. Only working hours, you will push this portal, and you can also specify the terminal IP. For example, maybe you want this IP 10.10.10.10. Okay, we only want this IP to push the portal. So whenever this IP connect, we will push a portal to their devices. So you can also specify this. And beside this, you can also specify some custom parameter such as IP address, MAC address, SSID, system name, user IP address, and MAC address name. Okay, so you can specify all this information inside the NCE campus. And on my left here, okay, we have the authentication process. So basically, this is how the portal page push policy works. Basically, when a user, okay, first the user will connect to our device and send a HTTP authentication request. Okay, so when our device receives this request, it will redirect. Okay, it will reply a redirection request to our devices, and then our devices will be redirected to our NCE campus. Okay, so this device will also send the authentication request to our NCE campus. So inside the authentication request, okay, we'll have all the information such as the MAC address of the device, the SSID, the IP address. Okay, so inside in the NCE campus, we will refer this information and to determine whether he will push the portal page or not. So if maybe you configure that, okay, this device should have this IP, for example, 10.10.10.10. Okay, this IP should push the portal web page. So when the NCE campus receive this information and he detect that this PC belongs to 10.10.10, so he will send the portal page to our devices. Okay, so these are the overall process for the NCE portal page. Okay, so beside portal authentication, okay, our NCE campus also support multiple user authentication. Okay, in NCE campus, actually we also support locally create account authentication, or we are able to support interconnection with social media, and we also able to interconnect with AD or LDAP to synchronize the user information, and we also able to interconnect with third-party database. Okay, for example, you can interconnect with SQL Server or Oracle database. Okay, and you can also connect to third-party HTTP server. Okay, we can set the authentication URL. So whenever the user try to authenticate, our NCE campus will communicate with this authentication URL. And we also support third-party Redis server interconnection. We also support token server interconnection and certificate authentication. Okay, so these are all the authentication that we support inside our NCE campus. Okay, so next. Okay, the next key feature that we have is the free mobility. Okay, the free mobility. So actually, what is free mobility means? Actually, free mobility allow one user to obtain same network access policy regardless of their location or IP address. So what does this mean is, for example, we have user A and then we have the policy A. This policy A is meant to configure for user A. So whenever the user move from this device to another device, and then now he connect to this switch, this policy will automatically apply at this switch just for this user. So in this case, you don't need to change any configuration on the switch. So this is what it means by free mobility. So basically it means that no matter where is the user, as long as it is the same user connect to the network, it will apply the same policy. So the user can connect anywhere at any time. So he will get the same policy. He will be able to access the same network, throughout their own network. So this is means by free mobility. So basically the advantages for free mobility is we are able to simplify network planning as administrator doesn't need to consider the IP address of the user. So in traditional network, if we want a user to able to use the same policy throughout the network, we need to specify the IP address for the user. We need to plan for the IP address for each user. But in our cloud managed solution, you don't need to plan it. We don't need this. Besides this actually enhance the control capabilities. Basically the user authentication information can be synchronized between network devices. So the authentication information will be synchronized throughout the network. So whenever the user connect here, from here to here, it will automatically synchronize the authentication information, and then it will allow this user to connect to external network. And lastly, the advantages of free mobility is it will able to improve the management efficiency. As we no need to, by using NCE-Campus, we no need to configure the device one by one. Just by NCE-Campus, you can configure all the policy to all the network. So these are the three main advantages. So beside this, free mobility actually allow us to implement something we call it as security groups. So these security groups, basically in the security groups, we can bind a same permission control policy to each security group. So for example, we have user A, user B, and user C. Maybe we bind this user A to sales security group. So whenever this user connect to the campus network, right, our NCE will detect, it will know this user belongs to sales group. So it will apply this permission to this user, and the user A will be able to access only the network for sales. So these are one of the benefit of free mobility. In traditional network, we are not able to create this resource group or security groups, but for now through NCE-Campus, we are able to achieve this one. So now you can assign each user into different groups, and each of them will have the same policy apply. The next key feature that we have inside CloudCampus network is terminal identification. So in NCE-Campus, right, we have the terminal fingerprint database. So whenever there's one device connecting to the network. Yeah. Hi. Let's continue. So whenever we have any devices connect to the network, our iMaster will automatically detect. It will detect what kind of devices it is connected, or it is either printer, or is it a camera, or is it a PC? So through this terminal identification, our iMaster NCE will able to detect the fingerprint from the databases. So how actually our iMaster able to know this is a printer, camera, or this is a PC? So NCE-Campus actually it will get the information from maybe MAC address, maybe from DHCP or LLDP and others. We will talk about this in more details later. So by introducing the terminal identification, okay, we can introduce automatically authentication or automatic authorization. Okay, basically here it means that in iMaster NCE, we can configure maybe, for example, we want all printer to be using MAC address authentication. So in this case, we can configure this configuration in NCE. So whenever a printer connect to the device, our iMaster NCE will automatically detect. He will know that, oh, based on the MAC address, this one is printer. So this is printer. So I will let him to use MAC address authentication. Okay. So these are some of the benefit for terminal identification. And beside this, through the terminal identification, right, we are also able to detect the bogus terminal. Okay, for example, maybe a PC is trying to fake its identity as IP phone. Okay, so by the terminal identification, our NCE campus will able to detect this is from the MAC address. You were able to know this is actually not a IP phone. It is a PC. So from here, it will detect and then it will change the characteristic of the device from IP phone to PC. So this, we can prevent any bogus terminal to connect to our devices, and it will report a bogus terminal alarm if there's these cases occur. Okay. So in terminal identification, right? Okay, our NC campus actually detect the terminal with two. Okay, we have two type of solution where our Campus Insight used to detect the end terminal. The first one is proactive detection, and another one is passive detection. Okay. So for proactive detection is our iMaster NC Campus will keep on scan and detect the end devices. It will keep on scanning the end devices. Once it detect there's one end devices connect to the network, okay, the end devices will feedback their information such as MAC address, or maybe from the DHCP information, or maybe LDP information. Okay, it will feedback to our iMaster NC. Okay, and it will display on our NC campus. Okay, so once it display, our administrator will able to view the identification result. So after that, if this device is authenticate, so our iMaster NC campus will deliver the configuration and policy based on the device. Okay, so this is proactive detection. And for passive detection is, instead of NCE campus keep on scanning, okay, instead of keep on scanning, now is our end device will connect to the switch, okay, and then once the switch connect to the switch, our switch will collect the fingerprint and report this fingerprint to our NCE campus. Okay, so once NCE campus receive this fingerprint, it will display the identification result for the administrator, and it will check. Okay, it will check whether this user or this device, is it an IP phone or is it a PC, and it should be able to access our network. So it will check all these details, and after if authorized, our NCE campus will deliver the configuration and policy based on the device type. Okay, so basically we have two solutions. The first one, proactive detection. iMaster keep on scanning the network, and then the passive detection is the end terminal will connect to our network first, then our switch will only report to our NC campus. So these are the two solutions that we have for terminal identification. Okay, so this is how our NC campus detect the device type. Okay, basically we can detect the device type using the MAC OUI, the HTTP user agent, the DHCP option, LDP, MDNS, SNMP query, and SNM and NMAP. So okay, in MAC OUI, if you know, in MAC address, okay, the first 3 bytes usually will be used to identify the manufacturer. So in this case, from the MAC address, we'll know what is the network device vendor. For example, is it Apple? Okay, is it Huawei? Okay, we can identify all this information using the first 3 bytes of MAC OUI. And besides, using the HTTP user agent, okay, inside the user agent string, it will contain the manufacturer, okay, information. It will contain the terminal types, the OS, the browser type, and other information. So from here, we can also get, and we also know what is the end device which is connected. And another thing is from DHCP option. Okay, as you know, different vendor will use different DHCP option. Okay, for example, we have on Huawei, we have the DHCP 148. Okay, and other vendor, we have maybe the DHCP 50, 55, 60, and 12. So from this DHCP option, we are able to know, okay, this device belongs to which vendor. And next is through LLDP. Okay, through LLDP DU, okay, inside there we have the device model information. So from here, we are able to detect what is the device model and what is the end devices. And next, through MDNS packet also contain the terminal model and service information. And usually MDNS is applied for Apple devices. Okay, so in this case, we are able to know what is the type of end devices. And beside this, we also use SNMP query and mmap to get the related information by querying the device information. Okay, by mmap, the OS and service of the terminal will be scanned, and we will obtain terminal model and OS information. Okay, so this is how we identify all the end devices using all this information. Okay, so next solution that we have is the campus network virtualization solution.